Hello there, my name is DOH-NANI from the Department of Statistics and Actuarial Science, KNUST, Kumasi, Ghana. So today we are also still continuing with the videos that I have uploaded, and we are going to now solve some examples in differentiation. We are going to solve some examples in differentiation, and I would want you to follow as much as possible, and you will just get the explanation right. Please kindly subscribe to this channel, click on the notification bell below. Please share this video, comment on it, as well as like it as well. Thank you very much. So there are some examples on the board, as you can see. I'm having 3 examples. Now, solving it in order from the first question. First question, f of x is equal to 6x cubed minus x, then 10 minus 2x. Now here we are going to use the product rule simply because there is an expression over here and another expression over here. Then these expressions are having a multiplication or multiplying, so we are going to use the product rule. That says dy dx is equal to v du dx plus u dv dx. In this case, we are going to represent this expression by v. Our v is equal to 6x cubed minus x. So our dv with respect to x dx is equal to 3 multiplied by 6 giving us 18x squared, then minus what? Minus 1. Then our u is equal to 10 minus what? 2x, which is going to give me, when I find the derivative, du dx, I'm going to get, because 10 has no variable, it goes off, then minus 2x, so minus 2. Now, my dy dx is then v, which is 6x cubed minus x, multiplied by du dv, which is what? Negative 2. Then plus u, which is so plus u, my u is 10 minus or 2x, multiplying the v dx, which is 18x squared minus 1. We can multiply this one through, giving us some expression like, so you get minus 12x cubed plus 2x. Then when we should expand this, that is plus. We should expand this one, we are going to get something like 180x squared minus 10, then minus 36x cubed, then minus plus 2x. So in that case, we are going to get something like minus 36x cubed, then plus 180 x squared plus 2x minus 10. We just have to find the like terms and then just add them together. So we are having minus 1 to 12x cubed and then minus 36x. So we are going to get minus 48x cubed. Then we have plus 180x squared plus 4x minus 10. This is going to be our final answer for the derivative. So you can pause the video and then you solve this example by yourself, and let's see how possible or how best you are improving with the knowledge you are getting from the expression. So we can find out that there is an expression multiplying by another expression, and henceforth we know that in this case we can use the product rule in solving this particular example. That is when we should represent our v to be equal to x squared. It means that we are therefore going to get an expression like 1/3, yeah. When we should use v to be equal to x squared, all in the expression negative 1/3, that is the cube root of x squared, then our u is equal to 2x minus x squared. So to find for the derivative of v, we have to apply the chain rule to also find for the derivative. Otherwise, you can also consider, okay, it is better to use the chain rule so that you do not find yourself fumbling or in problems. So I'm going to say k1/3. That is, I've represented my v is now k1/3. That is k is equal to x squared. Then my v is now k1/3. So my dv with respect to dk is going to give me 1/3k negative 2/3. That would be my dv dk. Then my dk on dx, I'm going to get what? 2x. Now my dv on dx is now going to be dv dk multiplied by dk dx. That is the chain rule. In that case, I'm going to get dv dk to be dv dk is 1/3, and my k is known to be what? X squared. So x squared all power minus 2/3. Then my dk dx is what? 2x multiplied by what? 2x. So I have gotten the expression for dv dx using the chain rule for the expression. Now, du dx is simply 2 minus what? 2x. 2 minus 2x, giving me, or can be factorized or simplified as 1 minus what? X, just as this. And now to find for the derivative using the product rule, now dy dx is equal to dy dx is equal to v du dx plus u dv dx. And now we know all of them because we have our v, we have our u, we have the derivative of v with respect to x and the derivative of u with respect to x, and henceforth we are going to get it as my v is what? The expression x squared bracket exponent 1/3 multiplied by my du dx, which is 2 multiplied by 1 minus what? X, 1 minus x. So that is my v du dx here. So plus plus my u. Here's my u. My u is 2x minus x squared. And my v dx, and this is my v dx, to be 1/3 multiplied by 2x multiplied by x squared, all on -2/3. Now, it is looking clumsy, and we would want to make it more simpler or simplified. So I can rewrite this expression as 1 minus x out. I'm factorizing 2 into bracket 1 minus x out. Then I'm going to get s squared. S squared 1/3. Then here, when I should factorize 2x, I'm going to get an expression plus x. That is 2x squared. Then multiplying x squared -2/3, all divided by 3. Why am I saying this? I'm factorizing this, and in this case, I can factorize 2x out, giving me the expression 1 minus x. Then, since this x is multiplying through the expression, this x multiplies with this, giving me 2x squared over here. And so I'll factorize my 1 minus x out. That is it. Then this one is a whole expression divided by 3, so divided by 3. So this will be our final answer. So this is an expression, a fraction. So now we are going to represent u to be the numerator, that is 1/3x cubed plus 2x exponent 1/4, all on 1/3. That is the cube root of the whole expression. So now, and our v, which is going to be 3x squared plus 2x cubed plus 4x plus 8, all exponent 7. And now we are going to use the quotient rule. So our dy dx is equal to v du dx minus u dv dx, all by v squared. And so our du dx can also be expressed using the chain rule. So we will represent this whole expression by k. So our